Hello everyone, welcome back to the channel. So today we'll be solving a new problem, that is maximum number of points from grid queries. So in this question we have given a grid. So as you can see, this is the grid and we have given this queries array. So what are these constraints? Okay, so let's see. So what we have to do, we have to traverse from this top left element. So like every time we will start with this one, because this is the top left element, right? So after that we have to traverse through it until we get the value that is greater than or equal to the number of or the query. So for example, we'll start with this one. So we'll start with 5. Okay, so now we have 5. So for this 5 we will check that, okay, if we'll start with this one. Okay, so we have 1. So if 1 is less than 5, yes it is. So after that it means that, okay, our condition is true. Okay, our condition is true, and then we can move to all the 4 adjacent directions, up, down, left and right. Okay, we will move this and this. Okay, so now we will keep it as a queue. Okay, so first we will always have 1 in the queue, right? After that we will traverse it. Okay, 1 and 2 is also in our list, so we will add 2 and 2 because we have traversed 1 here, right? So we will move ahead. See, we are saying that, okay, we are done with 1, so we will move ahead. We have the another one, that is 2. Okay, let's see. For this 2 we will check if this 2 is matching the condition. Yes, it is satisfying the condition. So what we will do, we will simply add the elements. So for these 2, what we have, the elements 3 and 5. So we will add 3 and 5 again, 3 and 5. Okay, so this is the element that we have added. Now we are done with 2. We'll cross that out, remove it. We will start with this 2. Okay, for this 2, let's check, is it satisfying the condition? Yes it is. We will check. Okay, we will traverse again. We have 5, but we have already visited 5, so we won't be adding that 5 again. We will be adding 3 because we haven't visited this one. Okay, so we will add this one also. So we'll add this 3 now. Okay, now we are done with this 2. Move ahead with this 3. Okay, is 3 is matching the condition? Yes, it is matching the condition because 3 is less than 5. So we'll check that. Okay, 2 we have already visited, 7 we haven't, so we will add that in our queue again. Okay, after that we are done. We'll remove 3. We'll again check for 5. Okay, so let's check 5. Okay, if this 5 is less than 5, no it is not. So we will skip this condition because in this question we have given that, okay, if we do not find the condition satisfied, we do not get any points, right? So we'll end this process. So what this point means is that, so every time we are every time we are popping out the element, suppose this one, if it is matching the condition, we are adding the point as plus. Okay, so this is what points mean. If we are satisfying the condition, it means that we are getting the point, right? Then we will add the conditions. So for this one, because 1 was matching the condition, we added 1. So for point, for this one we will have 1 plus, for this 2 we will have 1, for this 2 also we will have 1, this 3 will have 1. Okay, now we are checking for this 5, but this 5 is not matching the condition, so we will move ahead. We'll say that, okay, if this 3 is matching the condition, let's see, do we have 3 is matching the condition? Yes, it is matching the condition. And do we have anything else in 3? No, we don't have. So what we will do, we won't add anything in it, but we will add the point in it, right? Because 3 is matching the condition, so we will add the point. After that we will move to 7, that, okay, if 7 is matching the condition, it is, oh, I forgot to cancel it out. Okay, 7 is matching the condition. No, it is not matching the condition. We will do nothing, we will just move out. Now we don't have anything else in the queue, so our answer would be this. So what are these total points? I'll say TP. That would be 1, 2, 3, 4, 5. So the answer would be 5, right? As you can see, this 5. Now let's check for 6. Okay, you know the conditions that okay, we will get all the values for 5, right? Because you already know that okay, if we are checking the condition of this query, this will be now 6. We'll check the condition that okay, if it is matching, if you can observe that, I'll give you a hint that all the elements that are available for 5 would be available for 6 also, right? Because we are checking the condition if that is greater than or equal to, sorry, less than 6, right? So I know you get the idea. Okay, now we'll move ahead. Okay, we'll check for 6. We know that these things, these points will already be added for the points, right? Now we will check with the points that were not traversed, right? So we had this 5 and this 3, right? So now we will check for these two also. So for this 5 we will traverse again that okay, 7 we have already added, this 5 we haven't added, so we will add this 5. So it satisfies the condition, so we will add. We already calculated the 5, so we'll add one more again into it, right? So this blue means the second one, okay, this 6 that I'm traversing. Now we will move ahead, we will move to 7 now. So for 7 we will check that okay, 5 visited, this 3 visited, this one we haven't visited, so we will add this one also, okay, because it was, wait, my bad, I'm sorry. For 7 will not match the condition because we have 6, so we won't add 1 here right now. Such for that. So for 7 we won't do anything, we'll just move out. We'll again go for 5. So now 5 is this one, right? Because we have added this one also. So for this 5 we will check that okay, 3 visited, 5 visited, 1 we haven't visited, so we will add 1 now. Okay, so this is done and we will add that in our condition. Now check for 1 is matching the condition. Yes, it is matching the condition. Do we have anything else we can add? No, we can't add anything else in our 1, so we will simply move out and we will add one element also because 1 was satisfying the condition. Okay, so the answer would be 5 plus these new elements, that would be 5 plus 3, that would give us 8. Okay, this is how we will traverse. For 2 you can already calculate that okay, how we can do it. Okay, for 2 we will check that okay, 1 if it is matching the condition, yes it is matching the condition, we will add that in the queue. Okay, we'll check if it is matching the condition, yes it is, we'll add the count or point to 1. Now we will add these 2 and 2 in the queue, so I'll take queue here, 2 and 2 is added, right? So you must be wondering that how we would be knowing that okay, this 5 is a different from this 5. So what we will do, we will simply also add the coordinates into it so that we can understand that okay, this is a different one, this is a different one. Okay, anyways, moving ahead, so we will check that okay, this 2 and 2, now we will come to this 2. Okay, we'll check that okay, if this 2, sorry, not this one, if this 2 is matching the condition, so what should be the query? Q. No, it is not matching, we will move ahead, do nothing, again 2, do nothing, move ahead. So in this value we will have only 1, right? So this is how we are calculating this value. So this can be the brute force approach, as you have understood already that okay, we will traverse through each element. We'll start with 1, we'll check that okay, if it is matching the condition, if it is, moving ahead, if it is not, skipping it, right? And so on. Then for this query also we will do the same thing, use the BFS. We'll use the BFS to traverse. Again check okay, we are done, okay. After that next query, so like this one we will be using the brute force approach. Okay, now if you have seen one thing, that we are doing some repeated work, right? So as I have told you that okay, for this, suppose this query 5, we calculated some values. Then for the query 6, you already know that the values that you have calculated in 5 would be still valid for 6, and we have to calculate the other values that are not calculated by this 5. So this can be the basic condition. And suppose for this 2, okay, so if we calculated the values for 2, we already know that, okay, the values that are calculated by 2 can be used by 5, right? Suppose in this example, okay, so we are taking the value in 2, we are getting this one. So we know that, okay, for 5 and 6 we will be having this value, this point added, right? So for this 5, let's see, for this 5 we already know that, okay, this value, this part would be available in this 6 also. You can see that, okay, this part would be available by it, right? Because we are checking the condition, right? So this is the observation that, okay, if we can reduce the amount of repeated work because we are calculating this value again, but we don't have to, right? Because we are already calculating this value in here. Suppose if this is 5, for 6, if the value is greater than 6, or sorry, if the value is greater than the query in the next one, we already know that, oh, the previous one would already be having the values. We don't have to calculate it again, right? Suppose for this 6, suppose we had some value as 7, right? So you know that, okay, for this 6 we will have these values, right? We will have these values already. We have to calculate the values for 7 only, right? For till 6 we already have this value. I hope you are understanding this. So for that, you must have guessed that, okay, if by any chance our queries would be sorted like this, right? For just doing that, okay, if we are calculating this value, number of points, and we have saying that, okay, we have already seen this, we will not visit this again. You will say that, okay, for 5 we have done that, okay, we have seen it, we won't see that again. Then the next query, you already know that, okay, this is already strictly increasing, so you know that, okay, this 5 is already added, so we will add the points to this one only. We won't see this again, we will see the new ones, right? So this is how we will do it, okay? So we will arrange or sort this array in this order. We can there can be another problem that, okay, we want to store the values according to the queries. I think that is not a big deal because we can store this query indexes and preserve it, and when we get the answer, suppose for this 2 we get the answer as 1. So what we will do, we will simply add the value in the index of 2. So index of 2 was 3, sorry, the 2, right? So we will add 1 at the index 2. That's not a big deal, right? So for this value 5, we got the answer as 5 only. So what is the index of 5? It was 1, so we will add that in the place of 1. For 6, the same, 8, add the value to second index, because first index, sorry, because the index was 1 only, right? I hope this is clear. Now we know that, okay, first thing we will do is we will sort the array, right? Sort which array? The query array. Okay. Now the second thing is that, okay, we will do the BFS traversal, right? Traverse through each element. Okay. But there can be one issue, right? What can be the issue? The issue can be for this queue, for this BFS, we are storing the values as like 2 and 2, right? For example, it will traverse from this fashion. Suppose it added 5, right? But it's like that we have to get the values in sorted order also. The queries should also be sorted. Why? Because then we will check that, okay, if the element, if the query's top element, if this is sorted, if elements is sorted, then the top value we will check that, okay, if for this query, suppose we are having this 2 as a query, right? So we'll check that, okay, if in our queue, let's take it as 3, okay, and this is 2, okay, so for this query element 2, we will check that, okay, if the top element or the sorted element because it's the smallest one is satisfying the condition, it means we will go inside that, we can do, right? But if it is not, we will simply go out, we will skip this query. So this is the condition that okay, our current element should be less than the query element, okay, that is QUL. Okay, so if we have a queue already that okay, the smallest element in the queue is 3, so we know that okay, if our value is 2, we can't take this, right? Because the points we can't move the to the adjacent element of it, okay, so we'll simply skip it. After that we will suppose traverse with 5, okay, so the smallest element in our queue is 3, then we will know that okay, we can traverse it, we can find the values because 3 is the smallest, right? Then we can traverse again. So this is the intuition of it. So for that we already know that okay, we can use priority queue for that. So that is heap queue, right? So in Python we will use heap queue. So the three things are okay, we will sort the queue array. After that we will use heap queue for our queues because we can't simply use BFS queue. Okay, so for BFS we will use the heap queue. And for that we will check the condition. If it matches, add point, else continue. So this is the basic intuition of it, right? So we will just simply write the code for it. So the first thing would be we have to sort the queue query, okay, or queries. But to sort that, before that we have to store the values of our queries because we have to preserve the values, okay, the indexes, right? So we will preserve the index. So how to preserve the index? Simple is that okay, we can take a sorted query, right? So after that we will simply iterate through our queries. So our queries is like okay, so this what enumerates does is that we will take the indexes and also the values at the same time, okay, so we'll simply add the values that okay, this sorted query dot append will append the values that are two values, our main query and also its index. So we'll preserve it in our sorted query, okay. After that we will simply sort our query. For that it will sort through the query element, it will sort through these elements 5 6, 2 would be 2 5 and 6, and also in the it will also have the indexes, right? So it won't affect. So now we are done with that. This is the first part. I hope you're understanding that. So our part 2 was to use the BFS or heap queue, okay, so traverse. So for that we need couple of things, so I'll just use the some of the variables. One was the point, right, if you remember, and we will also have the max point that will store the result. So these m would be the length of the row, length of column, and after that point we will start with 0, and the max point would be an array that will initially contain the length of queries because this is what we have to return. Now there's one thing that okay, you already know that it will always start from the top left corner. We know that it will start with top left, it means that would be 0 0, right? That will be the starting point every time. So after that we will take that okay, the starting point would be 0 0. So in that we'll take a queue, okay, as we discussed, and after that it will take three things. The first thing would be our grid value, that is 0 and 0 for initial because we'll always start with that one also, okay. So these two things would be, I'll write it in the, that would be, the first thing would be the current value, okay, that we will be traversing from, and after that it would be the x and y index or I and j index, whatever you like, okay, the row and column. So this is the queue that we will be taking. So for using the heap, we just have to do one thing. We have to just type this heapq.heapify. What this heapify will do, it will heapify the queue array. So now this would be in a heap tree and sorted. right? Now for using BFS, we have to also take in consider that okay, we have to take the scene array because we don't want to repeat or see the array again and again. Okay, if you know BFS, you'll know that okay, we use the scene array, or I will take a scene set, right? You can take the set, or you can take array. It won't actually, I think, matter a lot because I think the constraints are not that too high. Are they? Are. Okay, never mind. You can use that. Okay, I'll suggest that most of the time you can use set data structure. That will work. So for the set, we already know that okay, we are looking into the top left corner. So for top left corner, what we will have? We will have 0, 0, right? This is what we have. And we are storing the indexes of it. So the right and left corner, right and sorry, not right, but row and columns, we are storing in it. Okay. So if we have seen, we won't see it again. Now we will simply iterate to our queries. So we will have the query and the index, right, in our sorted query, right? Now we'll check for the base condition. What are the base condition? That okay, suppose we have an element or the query element. For take this example. So for that we have the query element as 3. Okay. But the top left corner is 5, right? So then what we have to do? We don't have to do anything. We have to skip it. So we'll just simply skip it because the condition was our query should be greater than the current value. This was the condition. Is it matching the condition? The current value is 5. 5 is less than 3. No, it is not. Then continue, right? So we will do what? We will check that okay. If you can take the grid zeroth element. So for the reverse condition would be if it is greater than or equal to 3. Okay, and then we will continue. So I hope you can understand this part of it. This is pretty basic query. Okay, then what we have to do? We have to just continue. But before continuing, we know that okay, we have this array that we have to maintain. So we have to store the values also. If it is not, we are not adding the point, we have to add the 0 in it because that is the current value. Okay, so for that we have to do what? We have to just take our maximum points, and we already have our indexes in a sorted queue, right? If you remember that, okay, we are also, this is the current index or the real index of these queries, right? This is all what we were storing. I hope you can understand. So for that we will simply say okay, just add 0. If you don't add that, it will also be okay because you're already having the values as we have initialized it as 0. So here we have initialized it at 0, but for the sake of understanding, I'll simply add that. Okay, so you will check that, okay, know that okay, this is the condition. After that we will use the BFS now. So for BFS we need couple of things. So now we will simply move ahead. Okay, so this is the basic condition of our BFS. While we have a value in the queue, we will simply move ahead. Okay, now we will check the condition. So what is the condition? So the condition is if our topmost element of the queue, that would be this one, right? If it is any point greater than the equal to query, then we know that okay, it is the time to add that element into the queue. Suppose for this one, right, know that okay, we added these two values, right? But after that, in the second part, we know that okay, this value, the maximum, like the minimum of this two, this is not matching the condition anymore. If it is not matching the condition anymore, we will simply store the values as one that okay, we can't traverse more in it. So this is the end part of it. So that we will do here, right? So we'll store the values in our point, and we will simply break out of this loop because we don't need to traverse it more. Now, if that's not the case, we'll simply move ahead. So it means that, okay, we can add the values of our point because this is the valid condition, right? So after that, we will traverse again that, okay, we will pop the element from our heap queue. This is the syntax of popping the elements. So if you remember that in our heap we had the three elements, that was the current value and also its indexes. So that would be x and y or RRC, whatever you want or whatever you like. Okay, so after that, okay, we have these values. Why we are popping? Because we know that, okay, we have added that in our point. We have added that in our point. If you remember, if this was 1, we take that, we'll add that in our point. That we did take that, added that in our point. Okay, we take that like that. After that, we will simply check for its neighbors. So suppose for this 5, we will check that, okay, 7, 2, this 2 and this one. So we'll move in all directions. To move in all directions, we have to, or I can simply take that, okay, I can take one more variable in that. Suppose this direction, I can take, suppose 0, 1. If we are moving, like moving down, up, okay, and so on. So this is how I will traverse. So this would give us dx and dy, a value in, okay, we'll simply add the logic here, nx, sorry, dx y plus. Now we'll check the simple conditions so that we are not out of bound, like in this side or in this side. We don't want that, right? If this is the last element, we don't need this one and this one, right? So these are the basic conditions that I will check for. This is the main condition that, okay, it should not be in the scene. If we have seen it, we don't want to see it, right? So if we haven't seen it, we will simply add that, okay, we will now see you, that would be nx and ny, right? And we also add that in our queue. So to add that, we'll simply use this heap push, and what we have to push, we have to push two things. So this is the heap or the queue in which we have to push. So this is the current syntax. So what we have to push, we have to push the current value or the neighbor value, nx and ny, and also the coordinates, right? So I think this is it. And after that, once we are done with all the things in a while loop, right? So after that, we will simply add the values in our max points. That would be our point, right? Then after that, we'll simply return the value. I think that was it for this code. Let's run it and check if I have missed something. Okay, I forgot that. Okay, this should be a list. Forgot to add that. Oh, did I? That should be done. Okay. Right. So this is done, and we'll simply submit it. And as you can see, it is quite efficient. So this was the code for it. I hope you understand that, and if you have any question or doubt, just drop it in the comment section, and I'll see you in the next one.